This session we will see about the types of data and scales of measurement. To give an overview of what are we going to see in this session, we will see what is data, we will see what are the types of data, we will see what are the scales of measurement, and more importantly, why should we know what is the type and scale of measurement of this data. Right, so let's go one by one. What do we mean by data? Data refers to a collection of measurements or observation. So it's a collection. Now there is another word called as datum. This refers to a single observation. So this is a single observation, whereas data refers to collection. So the plural form is data and singular form is datum. Now let's go into what are the different types of data and how can we measure data. There are basically two different types of data. The first type is called as categorical data. The second type of data is called as numerical data. Now the name is very well self-explanatory. Categorical means the attribute of the variable is measured as categories or is in the form of categories. Again, the term is very self-explanatory. The observations or can be given some numbers. That's why they are called as numerical data. The other name for this categorical data is qualitative data, and as we quantify with numbers, this type of data can be called as quantitative data. Now let's go into these two types and see what are the scales in which these can be measured. This categorical data can be of two types. The first one refers to what is called as nominal. Again, the term is very self-explanatory. The attribute can be just given a name. Say for example, gender. Gender, we can say the person is male or female. It has no direction that male is superior or female is superior. So there is no direction, and there is no, we cannot quantify the difference. What is the difference between this male gender and female gender? That cannot be quantified. So just we can assign a name to that particular variable, namely gender. Another good example is religion. Religion again can be Hindu, Muslim, Christian, Sikh, Jain, so on. There is no there is no religion which is superior or inferior. So there is no difference, and there is no direction also. So there is no direction, there is no magnitude of difference. All are almost the same, isn't it? So that's what is called as nominal. The second type of categorical data is called as ordinal, or the second scale of measurement of nominal data is called as ordinal. Now again, the name is very self-explanatory, derived from the root word order. Here the categories can be ordered in a meaningful way. Say for example, a very simple example which you all can relate to. Let's say the size of shirt. It is small, medium, large, extra large. So here these are four categories in which the size can be arranged, and there is a meaningful order. Means if you go on an ascending, small, medium, large and extra large. So they can be put into an order. So there is some direction, but the difference, we don't know what is the exact difference between the small and the large and extra large. So there is no magnitude of the difference given, but they can be arranged in a meaningful order. To quote a good example from our medical side, if you look into the stages of cancer, there are stage 1, 2, 3, 4. So it can be arranged in an order, but the difference between stage 1 and 2 is not the same as between stage 2 and 3 or 3 and 4. So the magnitude of difference is cannot be made at all. So this is called as ordinal data. So categorical data, just to recapitulate, it is the data which can be arranged in or which is measured in terms of categories. So that's called as categorical data. Now I want to make a distinction here that sometimes we might be using numerical values to record these data. Say for example, the gender, let's take this gender. When we record it in our Excel spreadsheet or master chart or any chart which we want to get our data into, many times we might code as, say for example, male 0 and female 1. Now this does not mean that this data is numerical. Right? I'll just try to explain this with a simple analogy. Let's take a hotel which has a lot of rooms. Room number 109, room number 110, room number 210. Each room is given some numbers, isn't it? It doesn't mean that room number 109 is 1 meter less than room number 110. They are just attributes for the name, that's all. So here the numerical value 0 and 1, or again, even though they have numerical value, they are not numerical data, but still they belong to this categorical data. Why are we sometimes giving this numerical value? Because if you have a strings in computer language means alphabets. So if you have a male and female, it is difficult to take it for further analysis at some point. So it's always better to code these type of variables. So please don't confuse these codes with the numerical data. So even if you code, it is always a categorical data. One more thing, there's a special type of categorical data which can take only two possible outcomes. That is called as binary or binomial or dichotomous. Di means two, isn't it? So if you take gender, it can take only two possible outcomes. It can be male or female. Again, now there's a definition of third gender also. Or if you take a patient treated with a drug, he is cured, not cured. Disease present, absent. So these type of data is called as dichotomous data. Some people also call it as binary. And bi and di refers to only two possible outcomes. So that's about this categorical data. Now let us look into the second type of data, what is called as the numerical data. Again, the name is very much self-explanatory that these data we can measure or quantify in terms of numbers. This can be again divided into two types. First one is called as discrete. The second type is called as continuous. Again, both terms are very much self-explanatory. Here, the value can take whole numbers only. Classical example, number of students in a class, number of patients with a particular disease. It can be 3, 4 or 10, 12. It cannot be 10.5. A number of children by a family or a parent cannot be 10.5 or 2.5, isn't it? So it can take only whole numbers. Here, the second type, what is called as the continuous type of numerical data, it can take any number of unlimited values it can take. Say for example, weight. weight can be 20.5 kilo, 20.7 kg. So it can take any number of values in between two values, any two given values. So this type of data is called as continuous data. Right. Now, there is one more cautionary point here. Sometimes the variable, one particular variable can belong to different scales on depending upon how we measure that. Now let's take an example of how are we going to measure this height. Let's take, I am going to measure in my research work the height of a particular patient. If I just call these people as, say for example, tall or short, or I can classify them as, say for example, very tall, moderate, short, very short. Or I can measure the exact height in centimeters. Now if you look into, the variable here is height, but how am I going to measure that determines the scale of measurement. Now if I just say they are tall or short, it becomes a dichotomous because it can just take two possible outcomes. If I make this as tall, very tall, moderate, short, very short, it becomes an ordinal. That's a meaningful order, and these two are categorical data. Let's take the same variable, I can quantify in terms of centimeter. So that becomes a continuous variable, continuous type of data. So the same variable, how we measure, the scale of measurement determines what type of data are we going to get. Right. Now, one cautionary note as far as the continuous variable goes, as we told, we can measure in any way like this the height. But the problem when we try to measure height in terms of categories is that one of the advantages, it makes it very simplified. So that's the advantage. But there are some problems or disadvantages or limitations of measuring height in this way, that you lose lot of information. When someone asks what is the mean height, you will never be able to tell when you measure like this. And more importantly, when we have a continuous data, the test used for statistical purpose for a continuous data is always more powerful than the test for categorical data. So when we have a variable like height, it's always better you measure it in continuous, you can measure it as a continuous data, then if you need, you can always convert it. But if you measure it in categories, then you can never convert it to this. So please remember about this, that dichotomizing a continuous variable always has its disadvantages. There's a very good article in British Medical Journal, the cost of dichotomizing data. Please have a look at it and you will have a very good read about this concept, why we should not be doing when we try to measure these kind of continuous variables. Now let's come to the last part of this session. Why should we know all these different types of data and what are the scales of measurement? Why should we know? The most important reason why should we know this is that the type of data dictates what measure do you use to summary statistic, what measure will you use to summarize the data, and what type of test will you use for this to do if you want to compare these variables between two groups is basically dependent upon these type of, what is the type of data and what is the scale of measurement. That's why we need to know that. So to summarize this whole session, data is a collection of measurements, and datum refers to a single observation. It's of two types. One is called as the categorical data, the other one is the numerical. And we have nominal, we just, as the name implies, gives only name. We have ordinal, in which we can have a meaningful order. These two belong to categorical data. Numerical data can be discrete or continuous, and it's always better to measure numerical data as a continuous variable rather than dichotomizing it. And the most important thing, why should we know? This dictates what statistical test and what summary statistics are we going to use. So thank you very much. If you have doubts, please get back to me.